we had the whole SOHCAHTOA thing. Now the SOHCAHTOA stuff stood for what? Good. Sine of some angle was your opposite over the hypotenuse. Good. Very good, very good. So we had that. Also with that came the idea of really only one of two ways of setting up an algebra setup for side lengths. You guys remember that? Where you had, if you had to find a side length, the trig of some angle was x over a number, or trig of some angle was some number over x. When you were trying to find side lengths, there was only one of two ways that it could work. It was either the variable was, or the unknown was in the numerator, or the unknown was in the denominator. If it was, the unknown was in the numerator, that meant all we had to do was multiply out by the bottom. Whereas if it was in the denominator, we did the good old exchange O change. And then the very last little bit that we started to talk about was when you had to find an actual angle. So if you had to find an actual angle, that's when we had to work. I know. So great. So happy. Found my mug. You guys are all worried. Didn't feel right. Didn't have that character. We have in our house, coming in the garage, we have a little mudroom, and in there we built like a little locker thing for the kids to put all their stuff in, and it's freestanding, so it's not like there's a shelf on the top, so you can put stuff on top, like a little handheld shop vac type thing. You can put your coffee mug up there. Yeah. So apparently, I got home with a bunch of groceries, and I put my coffee mug up there, but I put it behind the shop vac thing, and it's kind of dark in that room, even with this is the same size as the little foldable little handheld vacuums for like small parts. It just happened to be right behind it, and you couldn't see it because it was you blended in because the room is like a real dark navy color. So if it's the light off, you've never have seen it. We don't leave that light on. We're just walking in and out of the garage. I didn't notice it until I knocked it off the shelf when I went to go get the shop vac. Oh, I'm coffee mug. Was it coffee? No, there's none in it. It was empty at least. But yeah. Oh well. But then the other thing that we wound up doing was when you had to find an angle. And remember, the buttons that you had to press on finding the angle was a little bit different. So I'm going to put trig of the unknown equaled a number over other number. And we don't know what those two numbers were. Could they be the same number? Yeah, absolutely. They could be. Yes, ma'am. Messing with you. Okay. Now remember, when I keep using this idea of just trig number, trig of something, trig of x, trig of theta, whatever it might be, that means it's sine, cosine, or tangent. This works for every single one of them. It doesn't vary. Okay, and this is what's nice about this. If we go through the same pattern every time, it works out real clean. Okay. Excuse me. So as we get into here, when we did the trig of a value, if we're trying to find the actual the angle stuff, what we wind up doing, if you remember, is so you guys can see it better. This is where it came into play where you had to use the inverse. Remember, the inverse of a trig basically undoes it, and there was a button on the calculator. Remember what it looked like? What was the symbol for the inverse? The negative 1 symbol. You guys remember that? So we would say that your value of x, the angle that you're missing, was equal to the trig inverse of whatever your fraction was. Okay? It was the trig inverse of that fraction. And a lot of times, remember, I always wrote it out with the parentheses around it, because what happens when you press the button that says trig? Parentheses open. Okay? And that's kind of the idea here. I'm trying to set this up in this scenario so that way, each and every time that get a problem like this, guess what you're going to do? The same thing. I know, go figure, right? All right. So what we're going to do today is quite literally the exact same thing we've been doing the past few days, but now we're setting it up and we're going to press buttons. Okay. But I'm still going to ask, and Thrower can attest to this, that we're always going to ask that no matter what, you always write down what you're going to be pressing in the calculator. So the steps that you've been doing don't change. The last little bit is that you're going to give me an answer round to the nearest hundredth. And when you round to the nearest hundredth, that's how many decimal places? 2. Okay. Let's look at an example. So if I'm looking at, let's see here. I'll blow this up a little bit. If I'm looking at an example like this, we're going to do the exact same scenario. I'll give you guys a second to draw that up. You're right, Josh. Guess what our first step is going to be here, guys? Just like we have been doing, the very first step is we're always going to circle our angle, and then we're going to label the parts that we know. So we circle our angle, and we draw to the side, opposite, and then we locate the hypotenuse. In this instance, that's what we're looking for. So what trig function are we going to use? Sine. So we write it out. The sine of an angle is the opposite over the hypotenuse. The reason why I'm writing it out still for a few more times, guys, so that we can kind of beat you over the head with kind of, having to remember that. And then we fill in our blanks. The unknown, the variable is in the denominator, which means my next step is to write it out as do your exchange up, change up. And now we get to the point of pressing buttons. You notice how we always write these out, we write them out as a fraction bar? I want you guys to get used to using the fraction bar with trig functions. It makes your life easier. Now, when you go to press the buttons here, a couple quick things to remind you. When you're doing this, you guys know how to tell whether or not you're in degree mode. Sometimes on your calculators, if you drop them or something gets reset or whatever, on the calculator, if you look in the upper right-hand corner, you'll see something that says DEG. If it doesn't say DEG, you're not in degree mode. Real easy way to change that out is you press the button that says mode and it rotates itself through. So, I don't have mine multi anymore. Excuse me. I think the software will be faster. So, right, like I was saying, right up in that top corner, it should say DEG. Okay. And if it doesn't say DEG, then means you're not in that correct mode. Really, the only time that mode would ever get changed for you guys, honestly, is if these don't have batteries, so it shouldn't have to reset itself through it. If you like for yours, since you don't have that one, yours you'll have to make sure if you ever keep your batteries on off, it'll default to radian. You have to go back and press the button that says mode, change it out. Okay. But I think yours should be the same basic idea, same position. It just doesn't do the radical stuff for you. So what we would do then in this one was it was a fraction bar. So we have to make our fraction bar. What was it? 2. Sine of 42. So we just go 2 over sine 42 and hit enter. I'm going to say always go to the nearest hundredth. That's going to be my general rule for all this. The more decimals that we round to, the more accurate of an answer we're going to get. And I see where you're going with this one. Yeah, this is like almost 3, but technically it's 2.9 is what I would round that to. And the reason that we do that, Josh, is because eventually, it won't be tomorrow, but on Thursday, we're going to start reusing values to get to the next piece. So if you wind up rounding too much, rounding it on one end, then the other one's going to be further off, so it becomes less accurate. Does that make sense? So That's why I always go to the hundreds, because it gives it a little bit more accurate one, but then it holds place for throughout the rest. And that's all you got to do. Did you guys notice when I had it in the denominator there, by using the fraction bar and I'm dividing out, it's okay if you don't close the parentheses, it'll still work. Just be careful if you have a value after it. When we get to things like that, you'll see it. Okay? And that's what we're doing today. That hypotenuse is equal to 2.99. And you would write that down. But notice we did all the work to get to that. So we've quite literally just added one step. Not bad, is it? And that was the whole point of taking that extra day or so to write out all of our steps before we get to this. Because as we get to this, then when you go to your calculator, if you wrote this down, but you accidentally hit cosine, you get a totally different number. But I know that you set it up right. Your thumbs were just stupid that time. All right? And that's the idea. If you write it out, it's easier for us to figure out what went wrong. It's so easy for me to know they hit cosine. Now, I can figure that out real quick with these numbers. It's pretty not too terrible. So take a minute and solve these two. Blow it up so you can see it better. Can you see that all right? 53, 11x, 39x, and 26. That's not bad when this showed up. Take a second, solve for x in both of those, write out the steps before you press the buttons. 2 decimal places. Bam. Where's yours? You gotta have them. So I yell at track too. Guys, from here on out, if you don't have a calculator, you can then fall over and cry. Really? It's the end of February. I don't have any pencils for that. You're the best. You're the nicest person that sits in that seat right now. Really? It's February in a math class. Yeah, man. Seriously, guys, I'm just going to start from here on out. You got to have a calculator. I'm not handing out any calculators. I'm going to hand out zeros. This is not a difficult thing. Crazy people. It's one of those tools of the trades, guys. If you don't have it, you're not going to make it, unfortunately. And here's the other nice thing about working through some of these problems like this, guys. Let's say by chance you do forget your locker in your backpack, forget your calculator in your locker, or you leave it at home, or you do something else like that. Can't you still do everything to set it up and get the value of x and then press button later? So it'll always be able to do stuff like that. Okay? That's the big advantage by writing these things out like this, because it forces you to do it that way. Now, did you guys have sine for the first one and cosine for the second one? You guys have it written out just like that? From there, it's just a matter of pressing some buttons. And if we do that, it's easier to press buttons as opposed to $15, sir. Yes, sir. So 11 divided by the sine of 53. You guys get 13.77? Then 26 cosine 39. You get 20.21. There we go. What's going to change when we find angles? What's that? What's going to be negative? The trig function, yeah, not the angle. We don't have negative angles. Actually, let me ask you this, Josh. Can you have a negative angle? You're exactly right. Because it just so happens I was doing this first hour with my Alpha 2 class. We're just starting to get into trig with those guys as well. We're viewing 30, 60, 90s, 45s, and how it builds out of what's called the unit circle. When you deal with the unit circle, you start at 0, 90, 180, 270, 360. You're going around counterclockwise, and those are positive degrees. If you go clockwise, they're negative degrees. So if I go down negative 30 degrees, it's technically the same thing as 330 degrees. So negative angles, you're right, just going another direction. If you guys ever get a negative angle, you're screwed up. You won't ever see that. So if you get a negative angle, you really know you did something wrong. Because it can happen if you don't do it. If something's right. So let me show you the other one. Let's say I want to solve for angle x. Say I want to solve for angle x. And these types of problems, just like how it was before on those worksheets and things that we were making, you'll see like a question mark. You might see an angle. It might say, "Hey, find angle A." There's going to be a bunch of different ways that they're going to write it out. And then this one, I'm just saying, "Hey, let's find this one." And guess what? You're going to set it up the exact same way. Sure. So always draw to your opposite, hypotenuse, process of elimination. What trig function will work with opposites and adjacents? Tangent. Very good. So I'm going to write it out. We know that the tangent of angle x will equal 12 over 35. And a second ago, Josh, you made the comment about using the -1 symbol. Remember, that symbol stands for inverse. So we write it out. The inverse, or x will equal the inverse tangent of 12 over 35. That's where the calculator comes in. I'll show you how to type it out here first. We're using the inverse. We have to hit second tangent, 12 over 35. A little fraction bar, 12, 35. And it looks exactly like the way I wrote it. And that's the idea. And you hit enter. 18.92. And there's your angle measurement. Question. For argument's sake, find y real quick. If I want to find y, what do I have to do to my sidelines? Right. Everybody see that? I've changed my perspective. I changed my angle. I'm no longer at the angle of x. I'm now at the angle of y, which means opposite angle y is a different sideline. I have to readjust my perspective. Remember how we talked about that? Now, this is my opposite, and this becomes the adjacent. What trig function do you have to use now for angle y? Tangent again. So what's happening here, since you changed perspective, your opposites and adjacents will change. And we still use the same inverse button, but I want to show you something that happens when you do that. So the inverse tangent of 35 over 12. We type that in. Inverse tangent 35 over 12. I get 71.08. Did you guys get that? What do those two add up to equal? Huh? What do those two add up to equal? I don't know. If I had a calculator in my hand, I'd figure it out. Ding, 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 ding. Did they add up to equal 90? Yep. That means you did what? You did math right. You didn't done goof.
So at this point, if you ask that, should they go through doing trig, or can they just do triangle sum theorem?
Trig.
You want them to do trig. Okay.
Because what happens if they did the wrong value?
Then they'll get 2 wrong answers.
Right. You guys understand what I'm saying by that?
So that can kind of be your check?
Yes.
Okay, use it as a check.
I mean, we're not there yet. We're going to do that more of that come Thursday. I'm just saying
Okay.
that for today, we're just going to find one side, one angle, things like that. But I figured this was good. This was a good example to show them. Because sometimes what can happen, guys, is that you're going to hear me say this a lot. And I know you remember this.
Yeah.
Reuse your given.
Right.
Because if you reuse the given information in a diagram, you're going to become less likely to screw something up twice. You can screw something up once, but you'd be harder to screw if you use wrong information a second time. There's no way you'll ever get it correct. And you'll see what we get as we get into that further. I just thought this was a good example to show that they should always, if those triangles, they can find themselves through. Try another one. Solve for angle y in this one, please. Solve for angle y. Please. Oh, I'm sorry. Hey, somebody go do it. I don't want to. I trust you? No.
Thank you.
Oh, sorry.
Do you want to
wait. Oh, I was looking at the wrong one. Bad.
And then you should have a degree, right? It's an angle measure, so you should have a degree symbol. Yes.
Does anybody have the pro version of the multi-view calculator by chance? It's pretty sweet. It's got the silver buttons on it. Does anybody, I know a couple kids in the other classes have this one. Any of you guys have this one with the black one with the silver buttons? It's the same, but to get the inverse, you have to hit the button twice. There's no second function.
Oh.
It's because the second functions are trig are calculus functions.
Oh, okay.
This one does integral. Vector. Yeah. Pretty great. Vector. Oh yeah, vectors. Distance, direction, and magnitude. Are we okay with trig-ish things?
Yeah.
It's not that bad, is it? Especially if you continually write it out in first steps before you press buttons. And that's kind of what we're working on. Have a generic roll through. Yeah, like I was saying, I've said this before with a lot of the stuff in the actual textbook itself. There's not a lot of really good problems in there, to be honest with you. The textbook itself is. I can say it, the textbook's not bad at trig. It doesn't do a really good job of putting all of it together. So that's why Mrs. Sawyer and I kind of keep making these little quick worksheets and things like that to make them go through. What we have on this one, you've got 8 sides, and you have 8 angles. I'm asking that you guys write out your steps just like we have been all along, but then at the very end, round to the nearest 100. Okay? I'll give you some time to we've done the same thing over and over and over again. This should become pretty simple. Right. You feel like rocking out with that annoying everybody super loud. And I realized this last week, I had forgotten to put some of the PDF files online from some worksheets, so I'm sorry about that, man. I put these all up, or they're already all up. I had extra ones that had homework, I had notes ones that you didn't really need to use because you guys were cruising through it, so. And you guys will be doing more of this stuff tomorrow. I won't be here tomorrow. I've got the NHS selection day, so we'll be sitting in an office all day long, going through lots and lots of applications. What's that? Yeah, it is a lot of fun. It's a lot of work. This year we have 83 to get through. In there, it takes a lot of time to go through all of them. So hopefully I'll be able to get home on time. You guys got any questions on any of this? You're all right. What do you think my suggestion would be to do on top of the page before you get working? Write down your quick rules for solving for x, whether they're denominator, numerator, or angle. Then have those examples in front of you so you can refer back to them. That way you don't have to overthink it.